Hi everybody. So I've put together this short video on honours at the Research School of Earth Sciences at the ANU to provide some background to our honours programme and to provide an overview of the structure of that programme for those looking to go into this in the future. In addition, I provide an overview of the courses available in an honours year, and I take you through some potential avenues for research projects. On top of that, I take you through the requirements for entry into our honours programme. I'll cover the scholarships that we have available, and I'll briefly point out where you go to apply for this programme. If I missed anything, please feel free to contact me, Rodri Davis, on this email account here, so honours.rses@anu.edu.au. Okay, so some key facts. First of all, our programme has a 1-year duration, so 1 academic year, although there are part-time options available. An honours year includes 48 units, and we split that up into 24 units over 2 separate semesters. The honours year is very different from any earlier year at universities. Okay, an honours year gives you an opportunity to further develop and refine the knowledge and skills that you've acquired as an undergraduate and to apply these skills to research. On top of that, an honours year provides a unique opportunity to acquire skills that add significant value to those gained during your bachelor's degree and to develop under supervision as an independent researcher and innovative thinker. In an honours year, you will undertake both coursework and a research project, and that research project will be focused on a topic of your choice. As an honours student, you're given more autonomy and responsibility for your intellectual development. You'll work mostly on your own with the assistance and encouragement of a supervisor and other academic staff, and you'll be working largely at your own pace. You make your own decisions, and you decide how your work and your research should proceed. So putting this all together, therefore, you can see honours as the best of both worlds. You're at a stage between undergraduate and graduate levels. Formally at the ANU, you're classified as an undergraduate, but your role is actually very similar to a graduate student. As an honours student, you'll receive training as an independent researcher. You'll experience some of the independence and self-direction required of PhD students, but you'll also have close contact and direction from your supervisor and the world-leading research group that you will be embedded within. Now, an honours or master's is very important if you wish to continue into a PhD and pursue a career as a research scientist. Even if you don't think that you want a research career, a wider range of career options become available with the additional training and experience that honours provides. Why? Well, it's because honours equips students with the scientific, technical, problem-solving and communication skills that they will need to successfully tackle the challenges of any job. Perhaps most importantly, honours is a very rewarding and social year, and it's one that most students really enjoy. So why would you undertake honours at the Research School of Earth Sciences? Well, first of all, RSES provides a world-leading environment for research-led education. The school has unrivaled analytical facilities and expertise across the entire breadth of geosciences. Globally, the school has been ranked 9th for Earth and Marine Sciences, and in geology and geophysics, we're 6th and 12th in the world, respectively. In all of these disciplines, we're top in Australia. Now, honours at RSES, we have 2 formal specialisations. The first is in Earth and Marine Sciences, and the second is in Physics of the Earth. And I will now take you through the structure of these specialisations and the different courses that we have available. So let's start with the Earth and Marine Sciences specialisation. Now, as I said previously, an honours year at RSES is 48 units in total. So on the Earth and Marine Science specialisation, 24 to 36 units of your entire honours programme can be dedicated towards the research project. All students are required to take our research methods course, and one course from the following three, so analytical techniques, data sciences, or computational geosciences. There are a number of other optional courses available, and depending on the nature of your research project, you can undertake these courses within the Research School of Earth Sciences or externally within the College of Sciences or across in maths, for example. Now, in terms of our core courses, the first one is obviously the research project, and this is the principal component of our honours programme. It involves a research project conducted under the supervision of a research scientist within the school. Research Methods is a compulsory course, and this introduces the research methods relevant to the earth sciences through a series of lectures, seminars, and workshops. On this course, you learn key academic skills and how to plan, manage, and present scientific research. It therefore underpins your entire honours year at the school. There's the Analytical Techniques course. So for those undertaking research projects which are laboratory focused, this course provides advanced training in analytical techniques, including the theoretical background and practical training in the lab-based techniques that will be applied during your research projects. For those undertaking projects on the more computational side of the school, we offer a course in computational geosciences, which introduces the fundamental concepts of computer programming and the Python programming language. And for those research projects that are data intensive, either in terms of the acquisition of data or the processing or the analysis of data, we offer a course in data sciences. Now, data science is the most powerful tool available for separating scientific fact from fiction. And in this course, we provide background in the statistical and computational techniques useful for the analysis and characterization of geoscientific data. A focus is placed on a conceptual understanding of how specific techniques work and the situations in which they can and cannot be applied. Now, as I said, our second specialization is in the physics of the Earth. And again, here, your research project can comprise anything between 50 and 75% of your honours year, so 24 to 36 units. Again, the required coursework is research methods and the choice of one from two courses, so data sciences or computational geosciences. And obviously, if you only take a 24-unit research project, you can take both of these coursework courses. Again, as was the case with the Earth and Marine Science specialisation, there are options for coursework elsewhere within the school and elsewhere across the college and the university. So potential research areas, I'm by no means going to cover all of these in the following two slides, but I just want to give you a flavour of the type of research opportunities available at the Research School of Earth Sciences. So we have projects available in biogeochemistry, which would focus upon nutrient, trace metal and carbon cycling in the present and the past oceans, with emphasis on silica and calcium carbonate biomineralizing organisms. We also offer a number of projects looking at paleoenvironments, and here the school specialises in environmental reconstructions on timescales that range from thousands to millions of years, from both marine and terrestrial environments. We offer projects in geochemistry and cosmochemistry, where the goal is to constrain the timing and nature of processes in geological and planetary systems, using chemistry, isotopes and mineralogy, plus field and petrological observations. And we offer projects in experimental petrology, where lab-based experimental approaches are used to study the Earth, its origin, its evolution, and its mineral wealth. There are a number of projects available in climate and fluid physics, which focus upon fluid flow problems relevant to the Earth using numerical modelling and laboratory experiments. There are projects available in Geodesy, which look at all aspects of solid Earth deformation and its fluid envelope, including the effects of climate change on polar ice sheets, sea level variations, and studies of tectonic deformation through earthquakes, InSAR and GPS. Again, there are a number of projects available in seismology and mathematical geophysics, with broad interests ranging from imaging lithospheric structures to studying the inner core to developing methods for imaging Earth's interior. And a topic that's close to my heart, computational geodynamics. And this is a field that integrates observations from different fields with the fundamental laws of physics through computational modelling to understand the structure, dynamics and evolution of Earth's mantle and lithosphere. Now, as I said, I'm not able to cover every potential research topic available in this short video, and a list of other research areas are listed on this website here. You'll find other projects in areas ranging from geohazards through to geobiology. Okay, there's a number of research areas within the school, and I'd strongly encourage you to look at this website to find potential projects moving forward. So the requirements for entry in our honours year, first of all, you must have a bachelor's degree with a major or an equivalent in a cognate discipline. Our cognate disciplines are very broad, so earth and marine sciences, physics, chemistry, biology, computer science, astronomy, astrophysics, physical geography, mathematics and engineering. To gain entry into our programme, you must achieve a weighted average that's equivalent to an ANU 70% from 6 final year courses in your cognate discipline, and you must have the written approval of a project supervisor for your research project. Now, for advice and support with finding a supervisor or for any other questions, please contact me at honours.rcs@anu.edu.au. The school and the college and the university have a number of scholarships available for honours students. So within the school we have 2 scholarships. The first is the Anton Hale Scholarship, and this is up to $10,000 per annum. There are up to 2 scholarships on offer, and the requirement is that you undertake a research project in the geosciences. Our second scholarship is the Regolith Scholarship. We offer one of these per year, and it's worth up to $5,000 per year. The requirements for this are that you undertake a research project in the broad field of regolith science. Now, as well as these school scholarships, the ANU also offers a number of honours scholarships that are worth up to $5,000 per annum. Okay, so I'd encourage you to take a look at this website to find out more information about the scholarships that we have available and the application process. So that's me done. Please come and join us at RSES for what would really be a fantastic experience and a fantastic honours year. You can find application information on the website that I list on the top here. If you have any questions, please contact myself at honours.rses@anu.edu.au. Thank you.